we're going to jump right back into section P7, where we had started working with complex numbers. Just a couple of quick reminders. Complex number is a number of the form a plus bi. I is the imaginary unit that is equal to the square root of -1, or sometimes we say that I squared equals -1. And we had left off on talking about all of this sort of patterning with powers of I. That's what we had finished with. So there's a few more things we're going to take a look at in this section. In particular, more back to that definition of what happens when we have these square roots of negative numbers. So if the b value is greater than 0, and you have negative b underneath the radical, then that negative comes out of the radical as an I. And the reason that it does, of course, is because what we understand this to mean, based on our earlier definition, is that we have the square root of -1 times b, and the square root of -1 is equal to I. So the I comes out, much like our pairs of numbers can come out once, the negative can come out as an I. And it's really important that you take this into consideration as you're working with this, and that you get the I out first. So on number 10, what we're taking a look at is we're taking a look at these negatives. You might be able to do these two steps at the same time, and if you can, that's totally fine. But it's important to remember that there's an I square root of 16 here, and an I square root of 25. There we go. Okay, so the negative parts are i's on the outside. Now, if you can do it all at once, that's great. What's the square root of 16? 4. So this is actually 4i. And what's the square root of 25? 5. So this is 5i. And then we can combine them, much like we did last time, so that we get 9i. Okay? So you should be at least showing me this step and this step as you're working through, simplifying this. It's really tempting on number 11 and others like number 11 not to get the I out first. And you actually end up losing some signs along the way if you're not careful because of that. So every time you see the problems that have the negatives underneath the radical, you will take the I out first. So this is I square root of 6. Now the square root of 2 does not have a negative, so it's just square root of 2. And then the square root of -3 has also got I square root of 3. So in this one, this step's perfectly reasonable to write down with the i's pulled out, because there isn't anything that's a perfect radical underneath like there was last time with 16 or 25. And then we're working with our basic algebra techniques that we've been doing all the way along, where we're going to distribute this to each of the pieces inside, each of the terms. So the first one will have an I, and then we'll have the square root of 6 times 2. I know I could write 12, but I'm actually going to be factoring it later, so I don't really want to merge things together when I'm going to have to unmerge them from factoring, right? So I don't really want to distribute that. And then over here, I've got I squared, because I have an I on the outside, and I have an I here on the inside, so I've got I squared. And then I've got that square root of 6 and 3. And again, the 6 and the 3 are underneath the radical individually, so now they're underneath the radical together. Whatever's under the radical stays under, whatever's not doesn't, okay? I don't know why I put a parenthesis there at the end, sorry about that. I need to break these down. So 6 is the same as 2 times 3 in both cases. I squared is also a -1, right? So we can write that as well. So if I break this 6 down in both cases, I actually see some pairs of things cropping up. Here's a pair of 2's underneath. Over here's a pair of 3's underneath. I also might notice that there's a negative here, so that's a positive. So in the front, now I have 2i square root of 3. The 3 is still underneath, so it stays underneath. Over here, this negative making a positive. I'll write down a positive. And then my 2 3's underneath will come out as a single 3. So I have 3 square root of 2. And again, notice in my final answer, I don't have any negatives underneath radicals. I don't have any powers of I. In this case, nothing can combine any further because one's radical 2 and the other one's a radical 3, right? Can't do that. So I'm stopped at this point. There's no more simplification I can do. Yes, Levi?
What happened to the positive one?
It multiplied. So this is minus a negative, so it's a positive. But anytime we just have a 1, which this one happened to be, we don't need to rewrite it because it's multiplication by 1. Good question. Any other questions? Okay, I have one more, I believe, in this section, I think. Is that true? Yeah, number 12, I think, is our last one. You probably recognize this. At least it's almost what you might recognize. What does this look like that you've seen before? Yeah, it's really close to the quadratic formula. Does anybody know what's not making it the quadratic formula? Can you tell? There's a plus or a minus missing. Yeah, so in the quadratic formula, this plus is plus or minus. So it's not quite the quadratic formula, but it's almost the quadratic formula. They're actually giving us some values that we're going to substitute in for A, B, and C. And they're coming about from a quadratic equation, of course, that's what it seems like, and this is where we're leading with this. But for now, we're just talking about the simplification of a radical. So we're going to evaluate with A equal 5, B equal -4, and C equal to 1. So the B equals -4 means I have the opposite of -4. If you want to just write that in there as 4, that's fine. Plus, I have the square root of -4 squared. Please do remember it is -4 that's being squared, so the -4 needs to go in the parentheses. I have -4 times A is 5, and C is 1. So it looks like that. All over 2 times A, which is 2 times 5. So if you didn't already do it, the opposite of -4 is a +4, so I have a +4 at the beginning. Inside, I have -4 squared, which is 16. And then I have -4 times 5 times 1, so there's one negative, so it's still negative, and then 4 times 5 times 1 would be 20. And underneath, I have the number 10. So perhaps you recognize right here, I know what 16 minus 20 is. It's -4, so maybe you actually just recognize that piece right there without rewriting one more time. But here's a 4, and I have a plus. What is the square root, right, of the -4? 2i. 2i. Okay, so the I is because of the negative. And then the square root of 4 is 2. You could write I2 if you want, but 2i is what we normally see it written as. 2i. My denominator is a 10. What's one more thing I can do? I can simplify that fraction. 2, 4, and 10 are all even, so I can divide all three of them, because there's 3 terms, by 2, giving me 2, 1, and 5. So my result is 2 plus I over 5. Or we talked about last time, if you were like checking out back of the book kind of problem like this, what they might actually do is split the fraction up and write 2/5 plus 1/5 I, because there's an understood kind of a 1 right here they're recognizing, so you might see that happen. I'm just fine with you leaving it like that, but I don't want you looking at the back of the book and think you did something wrong. So, any questions on that? All right, that's piece. Oh, yes, go ahead, Tori.
I'm confused about how you got 2%.
So we had 4 plus 2i. Were you okay at that point?
Yeah.
Okay, so each of the 4, the 2, and the 10 were all divisible by 2 because they're all even. So I divided each one of them by 2. So 4 divided by 2 is going to give me the 2. The 2 divided by 2 is 1. And then the 10 divided by 2 is the 5.
Oh, okay. Never mind.
It's okay. All right.